Welcome, everyone. Our speaker for the High seminar today is David Robinson, who will be talking to us about governing an algorithm in the wild. David is currently working on a book about algorithms that judge people, and the book will present a guided tour across education, hiring, and criminal justice that's designed to help readers ask good questions about how such systems work. David Robinson is a visiting scientist at the AI Policy and Practice Initiative in Cornell University's College of Computing and Information Science. He's a co-founder and managing director of Upturn, a nonprofit that advances equity and justice in the design, governance, and use of digital technology. David is also a co-director at the MacArthur Foundation's Pretrial Risk Management Project. His research spans law, policy, and computer science. He's designed and taught a Georgetown Law Seminar course on governing automated decisions, and he served as the inaugural associate director of Princeton University's Center for Information Technology Policy. He holds a JD from Yale and studied philosophy at Princeton and Oxford, where he was a Rhodes Scholar. David is also new to the Bay Area, and we're so lucky to have him here. Hopefully, after the talk, many of you can connect with him about his research. I want to add that we're not taking questions via Zoom today. If you'd like to submit a question for David, please go to the event page on the High website and click on the link that says Join the Conversation. David, I think you're muted.
Hello, everybody. Am I coming through?
Yep.
Wonderful. Thanks for joining us today. I'm really excited to share this work, and I'm looking forward to the discussion. So, defendants in courtrooms, applicants in welfare offices, teachers at school, homeless people seeking housing assistance, and a growing range of others are now increasingly likely to be judged by an algorithm. And yet in many of these settings, the human beings who hold authority over these systems are struggling to use them wisely. Policymakers often lack both the expertise and, frankly, the competence and self-confidence to ask vital questions about how an algorithm in their area of responsibility will work. Likewise, the people who are judged by these systems and others who may belong at the decision-making table often cannot readily understand how such systems work or effectively influence the design and values choices that the systems reflect. And that's a big part, for me, of the motivation for this work. At Upturn, for instance, we've worked on automated judgment systems in courtrooms where new algorithms are labeling some accused people as high risk, a description that can make the person sound dangerous. But in many of those cases, the algorithm is simply measuring the probability of a missed court appointment. In other words, the accused person may simply be at a high risk of forgetting their appointment or of lacking bus fare for the trip back to court. But if this detail of the algorithm's design is not clearly understood, then someone who just needs a bus pass can end up spending months in jail. It is all too easy and all too frequent for judges and other responsible officials to rush ahead without asking, what exactly does this algorithm measure? Likewise, the moral choices inside of an algorithm, like the question of how much risk it ought to take to jail a person, are all too often left to the software developers in isolation rather than being handled openly by a democratic process. And there are similar challenges in other domains. And just to make this concrete, if any of us find ourselves under arrest in the state of New Jersey, the arraigning magistrate, the judge who first hears from us, is going to use a grid like this to decide whether or not we can go home or have to wait in a cage instead. And what you can see here is on the left side of the graph, this is how likely a person is to miss their court appointment or fail to appear. That's FTA. And then on the other hand, across the top is new criminal arrest. And you can see that if you're in the bottom sixth on both of those risk levels, then this dark green square says to the judge, please release this person. ROR means release on your own recognizance, which means you've been arrested, but you can go home, no worries. Whereas as the risk levels that have been calculated increase, eventually over here, the advice is to put the person in a cage until their trial is resolved. And what's fascinating to me about this chart is I want to know who made it and how it was made, and analogously, how those similar documents for other high stakes algorithms are getting produced. Because it turns out in this instance, for example, that if you ask, well, who decided that people at a given level of risk should receive, for instance, in this case, a GPS monitor on their ankle, which is what electronic monitoring, or EM, stands for, the answers are quite hazy in New Jersey and elsewhere. So as it turns out, there's an algorithm that allocates kidneys for transplant in the United States. And when I started this project, I hoped that the way that that algorithm is designed and governed might offer a roadmap for other situations where better governance would be helpful. And in today's lecture, I'm going to tell you about the redevelopment of that kidney allocation algorithm. And I'm going to draw some lessons out of it that I think might apply to situations like that courtroom setting that I was just describing. Now, we should take a moment, especially in a forum that's defined by AI, and here I'm using the word algorithm, and I just want to be clear about the scope of what I'm interested in for this talk. By an algorithm, I simply mean a rule that is embedded in software, and I'm especially interested in algorithms that have high stakes for judging individuals. Okay, so how does this connect to the larger discussion on AI and governance? Scholars have proposed a range of potential strategies for governing stakeholder input into an algorithm's design. They've proposed transparency practices that are specifically tailored for the context of software, such as disclosure of source code or of an algorithm's decision logic. They've suggested procedures that could make the design process for an important algorithm more accountable, strategies that could be used as well to forecast and to test the impact of a potential new or changed system, and methods that could be further developed to audit algorithms after deployment and to adapt them to changing conditions. These proposals for innovative governance mechanisms are largely on the drawing board. Some scholars take inspiration from other cases in which a special purpose governance mechanism has been created for a particular kind of decision, such as environmental impact assessments or participatory municipal budgeting. Others have imagined new ways to protect longstanding legal and philosophical commitments, such as due process rights or transparency, in the light of new or newly pervasive technology. Still others are experimenting with governance practices for algorithms in laboratory settings. Meanwhile, policymakers have begun to craft legislative and policy initiatives, a few of which are starting to be implemented. So in order to develop my understanding of organ transplantation and allocation policy, and specifically to understand the new kidney allocation rules that debuted in 2014, I canvassed the scholarly and official sources about transplantation and organ allocation, including the medical literature, statutes, federal rules, litigation filings, and the proposals, comments, explanatory materials, and actual allocation policy documents published by the United Network for Organ Sharing, which is the federally designated nonprofit that runs the organ allocation process in the United States. There were scholarly and lay literatures that surrounded this, lots of debate was published, and finally, I conducted 10 semi-structured qualitative interviews with individuals who are knowledgeable about kidney allocation and who in several instances played key roles in the development and approval of the new kidney allocation algorithm. These include, for instance, the surgeon who chaired the kidney advisory panel at the United Network for Organ Sharing during the period when that committee developed and gained approval for the new algorithm. And also a data scientist from UNOS who was detailed to that committee and who produced many of the simulations that the new policies were based on. So a little bit of background about kidney allocation. It's a fascinating world. The National Organ Transplantation Act of 1984 created a national policy for the sharing of transplantable organs. A key motivation was the idea, and here I'm quoting from a document from that time, that each donated organ be considered a national resource for use and be used for the public good. NOTA, as it's known, created a legal framework for organs to be gathered from donors who are often, when we say donors, and we're talking about donated organs, we're talking about people typically who are on life support or who are, as it might be colloquially described, brain dead. And what often happens here, what's the typical case, most kidney transplants, someone was an organ donor, they unfortunately are in a position where their wish to be a donor can be fulfilled, and they didn't pick someone who they wanted to receive their organs. It's not a friend donating for a particular person, but rather is an organ that becomes available and has to be allocated. There's a shortage of kidneys, as there is for livers and other organs for transplant. The organs are scarce, and the law forbids a market in organs, and so they have to be allocated, that is, rationed to patients. NOTA directed the federal government to designate a nonprofit, non-governmental entity to establish, and here I'm quoting from the federal statute, quote, a national system through the use of computers and in accordance with established medical criteria to match organs and individuals who are included in the list of those who need transplants. UNOS, the United Network for Organ Sharing, and its predecessor organizations have been using software to match organs with recipients since at least 1977. Popular sources often speak of a waiting list for organs, but there is in fact not a first come, first served queue for these organs. Instead, whenever an organ becomes available, an algorithm managed by UNOS conducts what's known as a match run to suggest a prioritized list of prospective recipients for that particular organ. And each type of organ has its own matching algorithm. Kidneys, as it happens, are the most commonly transplanted solid organ in the United States. The kidney allocation algorithm runs nationwide and coordinates more than 10,000 kidney transplants each year from a waiting list that now numbers nearly 100,000 people. It reflects a complex blend of medical, logistical, and moral factors. So for instance, the big challenge in transplant, the surgery to remove a kidney from one person and put it in another was actually perfected in the early 1900s. But when you receive an organ from someone else's body, the major risk is that your immune system may recognize the organ as invasive and may attack it. And so there's a very complex process of matching based on antigens, which are the proteins in your body that stimulate an immune response, trying to find an organ and a recipient where there is less likely to be a conflict biologically. And that gets complicated because the immune system conflicts that can arise are correlated with social and demographic factors, including race, for instance. So on December 4th, 2014, a substantially redesigned version of the kidney allocation algorithm was introduced in an effort to make the system both more efficient and more equitable. The new algorithm reflected a decade-long consultative and transparent process that might be a model for us for other settings. The most important problem with the system before the 2003 beginning of this rewrite of the algorithm was that it missed clear opportunities to allocate organs in ways that would maximize the benefit available. For instance, sometimes an organ from a young and healthy relatively young, relatively healthy donor would go to an elderly recipient who had only a few years expected left to live, and so that organ had useful life that wasn't used for anyone's benefit. And conversely, a young recipient who had a long life if they received a transplant might get a much older organ and then would need to come back for another transplant. And so those kinds of outcomes were making people concerned. The waste was not only a moral problem, but also a legal one, since the federal regulation that controls allocation requires equitable allocation policies that are, quote, based on sound medical judgment and seek to achieve the best use of organs and avoid wasting organs. Okay, so what happened over this period? And here I'm simplifying a long story. But in the decade between 2003 and 2013, the United Network for Organ Sharing led a policymaking process that culminated in a complete rewrite of the kidney allocation algorithm. There was extensive notice and comment. Each proposal was published, explained, publicly simulated, and publicly debated. The main topic of debate over this time, and the primary dimension on which these successive proposals varied, was a fairly straightforward and clear moral question, namely, to what extent should patients who will benefit more from a transplant be favored over those who will benefit less? The more and less here are life years gained from transplant, is the way that this was conceptualized. So utility, as the debate was framed, meant maximizing life years gained from the pool of organs, and equity meant giving an equal chance to all in need. Many other questions also got some attention in this debate and in the record, including racial equity, access for patients with highly sensitized immune system, and a number of other factors. The committee's first proposal, which came out in 2008, would have maximized what they called LIFT, life years from transplant. And it was immediately controversial because in order to maximize the total amount of life years that this algorithm managed to save, there would be a substantial decrease in the number of older patients who would receive kidneys. The proposal's authors, to their credit, held a public forum to seek feedback on this plan, and at that forum described not only the gain in life years, but also the shift away from older recipients that this proposal would entail. The second approach, which is known as the 2080 proposal, introduced something called longevity matching, which was a really neat idea, both at a moral and a technical innovation. This was to say, all right, let's imagine we don't want to change who gets an organ. Let's imagine we want to continue to give everyone a more or less equal chance based on how long they've been waiting, whether they happen to be older or younger. Nonetheless, we can match the youngest and healthiest organs to the youngest and healthiest recipients from among the people who are going to get an organ at all. Without saying we'll only transplant into the young, we'll say we're going to route the organs differently. So in this proposal, the 20% of youngest and healthiest kidneys in the pool would go to the 20% of youngest and healthiest recipients who were waiting on the list, as found by something called an estimated post-transplant survival score. Notice that this changes the efficiency, but need not change who gets a transplant. This second proposal was forecast to cause less reduction in access for older candidates than that first proposal had. However, the Office of Civil Rights opined, so I should say for the remaining 80% of organs, the 20% were longevity matched, as I've just described, and for the remaining 80% of organs, this second proposal would have done something called age matching, assigning priority for each organ to recipients who were within 15 years of age of the donor. So this second proposal would have caused less reduction in access for older candidates. However, the Office of Civil Rights within the Department of Health and Human Services opined in August of 2011 that the age matching part of this proposal would likely violate the Age Discrimination Act and therefore wouldn't have support from the federal government. The third and final approach, which is the algorithm we ended up with today, was published in September of 2012. It abandoned age matching for the bottom 80% and reverted to a system more focused on waiting time, while keeping longevity matching for that top fifth of organs and recipients. And I thought that that's where this story ended, with the adoption in 2014 of a revised algorithm and an analysis of its results. And I should say there are many beautiful procedural features of this process. The algorithm is published in a way that any of us could easily read. The performance data every year is published and analyzed by an independent third party, not by UNOS, but a different nonprofit that does the auditing of the performance of the algorithm. And there's tremendous amounts of documentation, and including comments from lay people. For instance, there were at the public forum debating some of these policies, when the idea was we're going to favor the young, one of the moving presentations was from a patient who has polycystic kidney disease, which is a disease that is genetic. You get diagnosed early in life, and what it does is gradually degrade kidney function until, unfortunately, later in life, you end up needing a transplant. And what this patient said to the committee was, you know, if younger and healthier recipients get priority for organs, then I could get punished for taking good care of my health and for maximizing the amount of time that my original kidneys last. Because the better job I do of taking care of myself, the older I'm going to be when my kidneys fail and I begin to need a transplant. And so it was testimony like that, in part, that led to the changes that were ultimately made before the system was revised. But as it turns out, the debates that happened within the rewrite process for this algorithm were only one part of the story. A new and unexpected chapter of the kidney allocation story begins actually with a lung patient, a young woman named Miriam Holman, who found herself in November of 2017, that's to say 3 years after the kidney algorithm had been rewritten, in urgent need of a lung transplant. Ms. Holman sued UNOS over the stark geographic disparities in lung access, disparities that in fact exist for all types of organs, including for kidneys. Her complaint was that the whole system is based in part on geographic divisions of local, then regional, then national allocation, and that these local territories, known as donation service areas, are arbitrary because they evolved when transplant was brand new and are basically an artifact of which nonprofits started coordinating transplants in which places. So, for instance, with lungs, so she was at Columbia University's hospital in Manhattan, and if the lungs that would have saved her life became available just across the river in New Jersey, the way the lung rules work, they would have gone to anyone in New Jersey who was waiting for lung transplant, even if less urgently than she, and even if that recipient was further away than she was, geographically speaking, and so the organ would have to travel a longer time, which degrades organ functioning. So she sues and seeks an emergency intervention from the federal court. And as it turns out, geography is now and has been for a long time a central fault line in organ allocation. The donation service areas are arbitrary, and waiting times, and this is what's depicted on the graph that I'm showing you right now, waiting times for a kidney can vary by a factor of up to 20 between geographies. Wealthy patients can afford to be listed in multiple transplant centers in different regions. And transplant centers in places that have shorter waiting times, especially in the Southeast, do a brisk business in domestic transplant tourism, and therefore have a vested interest in not allowing the system to change. At a practical level, it may be true that some amount of localism in transplant allocation is inevitable for reasons I'd be happy to delve into that basically include the importance of geography and travel time. But nobody imagines that if you started with a blank slate, you would end up with a patchwork map of geographies that exist today. Anyway, Ms. Holman sought a preliminary injunction. The judge was sympathetic, and UNOS acted swiftly. After years of delays in the lung allocation debate, the whole system was transformed in a week to use a radius around each organ, each donor hospital, rather than fixed geographic boundaries. Then a second suit a few days later was filed that raised the same objections against the liver allocation system, because again, these donation service areas are common to all organs. And that suit was ultimately led the federal government and the United Network for Organ Sharing to recognize that they have the same problem, including for kidneys. And the kidney allocation system is being remade now in haste to eliminate its most basic geographic building block, something that the 10-year-long extensive, careful debate, this model procedure for making moral choices relevant to an algorithm, somehow barely touched upon. So if we look here at, this is an analysis of all the different factors that make a difference to whether someone gets a transplant. And it's for statistics people, it's a Cox proportional hazards model. And these are factors along the x-axis that are supposed to not make any difference to whether you get a transplant or not. Other factors are supposed to matter, like how compatible you are with the organ, but these things are nominally irrelevant. And so you can see here that these are ranked in descending order by the extent of difference they made in your month-to-month likelihood of receiving a transplant. And the thing that made the biggest difference, you can see the blue bar here with the 0.57 standard deviations of access to transplant. That's DSA, is donation service area. Those are those arbitrary geographies that I mentioned. So which of those you're in makes a huge difference, is what this chart is telling us. Okay, so what can we learn from this experience that's generalizable to the governance of other algorithms? First of all, I would argue, I'll give 4 lessons here, or rather, I'll offer 4 inferences that I personally come away with from this process. First, special new ways of getting public input into the design of an algorithm can indeed be valuable, and we saw that demonstrated here, but they are critically constrained by existing legal and political authorities. So for instance, in this case, the longevity matching idea that allowed organs to be more efficiently allocated among the people who were to receive them was an elegant technocratic incremental improvement in the system that did emerge from this consultative process. And I would point also to another benefit of the process, which is that overall, it helped to generate consensus about what an equitable kidney allocation algorithm would look like. Sometimes in the literature about getting input into the design of an algorithm, there's a supposition that's tacitly made that what we're really doing is going out there to measure some static thing in the world that is, what does this community want? Or what do these individuals or these stakeholders want from this allocation logic or this AI system? And in this case, at least, one reality that was illustrated was that this long and careful consultative process helped actually to create the opinions of the stakeholders and people's opinions, for instance, converged over time that just maximizing life years from transplant was morally unacceptable. And on the other hand, that taking some steps to increase the total benefit from the pool of organs was morally necessary. But even though stakeholder input mechanisms demonstrated here that they can be valuable, what was also shown was that they are critically constrained by existing legal and political authorities. They saw the geographic issue, and I got this in my interviews as well, as I went back to people and said, hey, here was this huge moral problem that didn't come up at all in this 10-year debate. What gives? And what they said was, that was a third rail. We couldn't touch it. We knew that we couldn't get political consensus in this consensus-seeking model we were in order to change the geographic basis of allocation, because each of these territories is owned by an organ procurement organization, that's what they're called, that has its own political interests and wants to continue existing and so on. And so as it turned out, everything that the specially designed algorithm editing process was doing was subject to review. And indeed, the federal government at one point said this would be age discriminatory and you can't do it. That was the federal executive branch, and that changed things. And then in the end, the federal courts became involved. So I think that's kind of a mixed verdict on special new ways of getting public input into an algorithm. Second lesson I would say is that transparency is indeed valuable, but it benefits experts most, and official disclosures, are no substitute for firsthand knowledge of how a system works. And I can't convey without sort of pointing you to the piles of documents, or just if we had a video montage of puzzling through all of these pieces, it's not something that an individual in reasonable time can reasonably get up to speed on. Participation in the process, even understanding of the process, is resource intensive. So even with lots of transparency and with many mandated disclosures, the complexity of the enterprise makes it difficult to access meaningful participation. In reality, for all the hours spent poring over documents, a few minutes of careful conversation with people who were centrally involved totally changed my perspective. And I think that as we think about how to generalize access to that decision-making table where the courtroom algorithm or the welfare algorithm or perhaps the hiring algorithm or something else is being designed, what we need to bear in mind, I would say, that comes out of this experience is that disclosures are indeed helpful, but we also need access to firsthand expertise and firsthand lived experience. What does it look like to be having to decide who goes into the jail cell and who doesn't, or to be overwhelmed by that stack of resumes? Those lived experiences, if we don't know what that's like, then the algorithm influencing those decisions is going to be something that we're not fully prepared to talk about. And so how people get social access to that kind of lived experience, I think, becomes a necessary part of our broader conversation. Third lesson, the design of an algorithm allocates attention. It brings some normative questions into clear focus while obscuring others. Several moral controversies during the development of the system could be mapped directly onto features of the algorithm itself, making them relatively easy for people involved in the governance process to observe, debate, and modify. For instance, debates over utility versus equity involved how to allocate the already available organs to the already listed patients within the already established geographical framework. It was resolved through the longevity matching, as we've discussed, even for things like racial equity gaps, where it's less likely if you're African American that you receive an organ, partly because of being more likely to be in blood type B, where fewer donated organs are available. And it turned out there were ways to change that by allowing some organs that weren't blood type B to be transplanted into recipients who were blood type B, and that narrowed some of the racial equity gaps. Similarly, for highly sensitized patients, there were changes that were made to the allocation procedure. On the other hand, the arbitrary barriers between donation service areas were something that the kidney allocation algorithm and the people governing and debating it took for granted. Those barriers can represent huge disparities, but weren't up for modification. And by the way, the ability of wealthy patients, like Steve Jobs in search of a liver is a famous example. I believe he ended up in Arizona, not because he lived there, but because the list was short there. The ability of wealthy patients to multi-list across transplant centers is etched into federal law. That's a serious advantage that amplifies socioeconomic disparities, but is beyond the reach of stakeholder governance to modify. And there were other things as well that were important but didn't get central attention. For instance, one of the groups that gains the most from being transplanted in terms of how long they'll survive, and I should mention, people probably know this, but if you don't have a kidney, you can live on dialysis and have your blood filtered by machine, but there are tremendous health risks for each unit of time that you spend on dialysis. And young diabetics, as it turns out, are a group that particularly do poorly on dialysis and thus get a particularly large marginal benefit from receiving an organ. And it turns out diabetics don't only need kidneys, they need pancreases too, pancreata, as the Latin alert like to call groups of pancreases. One of the things that was happening in the background of this debate was that there was a decision made in midstream that although this algorithm that was being debated over the 10 years would continue to allocate kidneys for people who only needed a kidney transplant, there'd be a separate process to allocate kidneys for people who need both a kidney and a pancreas, which is a group consisting entirely of these diabetic patients. And they would go first. Whenever a pancreas became available, the kidney would travel with it from that donor patient who had that donor pancreas. And the effect that that had was skipping those people to the front of the line, and that's about 10% of the transplants that happen in a year of kidneys from deceased donors, which means in effect that although there was this 20% longevity matching was the centerpiece of the eventual new algorithm, which changed the allocation of approximately 1 in 5 of the organs, there was this other thing that happened midstream in the background that changed where 1/10 of the organs went that was scarcely documented at all. And it was only in oral history with the people who had sat in those committee rooms that this became totally clear to me. Again, the algorithm is going to put certain moral choices front and center and obscure others. And fourth and last, and then we'll open to your questions, the public infrastructure of analysis and evaluation, the auditing of algorithm performance that we saw here, the annual reports of how the kidney allocation process is going, the analyses like that chart I showed you earlier of different factors and how much inequity is introduced by each factor, that's really valuable too. It allows people to have a common point of reference. It makes participation easier by democratizing the work of analysis and not forcing people to reinvent the wheel. And I think that that overall is a very positive sign for those who've urged public analysis, public auditing of high stakes algorithms. So thanks very much, and I'm looking forward to your questions.
Thanks so much, David. So I've been going through and following on Slido, looking at some of the questions, and if people have any more questions, you can also post them there. So going through with the Slido questions, one of the first ones for you, David, is can the geographies used to define the DSA, the donation service areas, really be described as arbitrary? Can you go into kind of discussion in your research? Did you find out how those areas were defined?
Yes, the answer is emphatically yes, they can be described as arbitrary. They emerged from cooperation among hospitals before there was any national system and before organs could easily be shared. And there were advancements in immunosuppression that makes sharing easier. But before those, for instance, UNOS itself emerged from the Southeast Organ Procurement uh, 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 Organization, which was a group of hospitals based in Southern Virginia. And the territories, and I'll see if I can grab a map because I think it's illuminating. The territories are, there are 50 plus of them. Some of them are not geographically contiguous, so you have one organization owning several regions. The amount of territory is vastly varied. The number of people in each territory, the number of transplant centers, the number of available organs, on none of these dimensions is there consistency among those regions. And so even people who have vested interests in the continuation of the system will in general concede that there's arbitrariness that's at work there.
Thanks so much, David. So another question that came in, what was the argument in favor of age matching?
So one of the big arguments there was that it would ensure, it was one effect it would have is that it would ensure that older patients did get access to more organs, because many of the people who become organ donors are older, particularly when you look at the plus or minus 15 years band that was going to use. And in fact, they looked at different numbers of years to create that age-based sharing band. They looked at, well, what if we did 5 years or 10 or 20? And they picked 15 because with a plus or minus 15-year band, people's access to organs was approximately similar no matter how old they were when their disease began. But there was discomfort in the federal bureaucracy about using age so explicitly to control the rationing. And it's interesting, you might wonder, as some scholars have, if plus or minus 15 years was an unlawful use of age that was age discriminatory, then why is estimated post-transplant survival score any better, which is heavily dependent upon age and which is used in the algorithm today to decide who's in that top 20%. That's what they're in the top 20% of, is the distribution of estimated post-transplant survival. But somehow that was more comfortable. It's more medical seeming and less, it's not exactly explicitly using age. Maybe there's some dignitary benefit from using a calculated prediction instead of explicitly using age. But in any event, that's the system we've got.
So another question, somebody said this update process seems very impressive, right? The process through which the kidney allocation algorithm was updated, but also time intensive. Do you have any thoughts on the good versus perfect trade-off for updating the algorithm?
Yes, and in fact, I'll quote a person who was very involved in that process. It'll take me a moment to find, but yes, the 10-year process, which by the way is peppered with instances in which people said, oh, we'll be done in a few months with this process. That was something people thought almost all the time for 10 years. So Dr. Mark Stiegel, who's quoted in my manuscript, he says, you know, there's a time frame that you want to accomplish something in. This took 10 years, and 10 years is not acceptable. Let's be real for these kinds of things. At the same time, he also said, the Supreme Court is also a good example of social change has to precede legal change. And with any controversial issue, there's always going to be people against it. What we did, we probably kind of mimicked somehow that kind of hybrid process that is simultaneously both reflecting and shaping the community's beliefs about what an acceptable algorithm would look like. The competing values are irreconcilable, and here I'm quoting the surgeon who ran the process, quote, at the end, we make some sort of sausage.
Thanks. So one of the questions we got is, what's one piece of literature you would point to understand public and stakeholder input mechanisms better? Just
I suppose that I'm excluded from mentioning my own manuscript that'll be out shortly on this and has a literature review uh, on this. I would say, in terms of stakeholder input, uh, specifically, there are different kinds for different sorts of algorithms. My colleague and friend Margot Kaminsky has an article out recently called, the title of which is Binary Governance. And she talks at some length about the spectrum of different proposals that are out there. And I really admire and partly follow the structure of her literature review in reviewing those options myself.
So, do you have any recommendations for a process that algorithm creators can follow to try to identify certain blind spots? Maybe in looking at the other cases in your book too, have there been any ideas about this coming up?
Yeah, I think, there's a temptation to believe, and it's a natural one, that the moral stakes, and I came into this project feeling this way, that the moral stakes of an algorithm are controlled by pieces of the software, that really the place where the moral problems or the moral help or whatever happens is in the running code of the system itself. And I think one thing that we learn from this and from many other examples is that that's not completely true, that the social surroundings of the algorithm are very important to understand. So for instance, you can have a whole long discussion about, okay, who from the waiting list of kidney transplant recipients, people who need a kidney, who's going to get one? But another very important question is, how do people get on the list in the first place when they are sick and need a transplant? And as it turns out, there are stark differences based on the quality of medical care that different people have in the United States in terms of how likely they are to get onto the list for the transplant that they need. And so once that was recognized, one thing that changed when the algorithm got rewritten was that instead of counting your waiting time from when you join the list, they count your waiting time from when you first began to need dialysis, which is a relatively objective, relatively consistent marker in the course of your disease. But in order to know that that algorithm needed to change, there needed to be an input process that got the social pieces, including exclusion from the waiting list, into the awareness of the people who were actually writing the code. And so I think what that translates to for algorithm designers is there needs to be a process where those values are coming in from outside of the engineering team, not because engineers don't have moral compasses of their own, but instead because validity and legitimacy are a joint product and not something that can be produced in isolation. And so sometimes that might mean, if you're in the position of making a system, it might mean exerting some pressure on whether it's management or whoever is specifying what the work is, to say, we need to bear in mind here, and we need to find ways to allow for input into this process from outside of the technical folks. And I would also just mention offhand, at the University of Washington, at the Tech Policy Lab there, they have a process called the Diverse Voices process, where they actually have, for instance, methods for setting up workshops for getting stakeholders to provide input into how a system is designed. So that's one illustrative example, and there are others of people finding out ways to do this practically.
So, you've mentioned the equity and utility trade off a few times. Do you think there can be an escape from that trade off?
Yes, there could. And that's another of the things which isn't discussed in the allocation discussion, which is ultimately this trade-off is about scarce organs and people who need kidneys. But there are a number of things that are underway that are trying to change this. Most centrally, for many years, people have dreamed of being able to transplant organs from animals into humans. So for instance, and there have been experiments, people might have read about other things like heart valves or some other smaller things, but people are trying, it's known as xenograft, when you transplant across species lines, and people are trying to figure out the immunology and the bioengineering of that. There are also efforts underway, including here in the Bay Area, actually, to produce a artificial kidney that's a manufactured ceramic object with certain biological elements that are inside it that they filter the blood, but the immune system, the larger T cells can't get through to conflict with them. And so those sorts of things are, could change the whole set of assumptions that underlie the algorithm. And then, less exotically, but equally important, reasons why people need kidneys are socially determined. So in the African American community, for instance, there's a 4 times as high burden of kidney disease as in the rest of the United States. And a big part of the reason is that factors like high blood pressure, diabetes, basic health problems, even stress are correlated with kidney disease. And so, one way out of this conundrum is to address more directly those underlying drivers of disease.
David, was decision explainability built into this system?
So I would say that the answer is effectively yes, even though people weren't using the word explainability. They weren't framing it in the way that some of those discussions are framed. But the scores that are used to decide who gets an organ, like we were just discussing the estimated post-transplant survival score as one illustration, those are they're public calculators where you can see what the weight is of each factor. You can input your own or example demographics and see what the resulting score would be. And there also are these extremely detailed audits of overall how is the system performing. So you find out not only that you were at the top of the list, but also what was happening with the lists and with allocations of organs overall. It's important also just to mention that who gets the organ isn't totally controlled by the algorithm. The algorithm does the matching, and that leads to offers of organs. But ultimately, each time an offer gets made, someone's transplant surgical team might choose to turn that offer down if they think it's inadvisable for the patient. And so when we look at outcome data, we're not looking directly necessarily at the algorithm itself because there are these other factors.
So, David, in the process of doing the literature review, were you looking at what best practices were outside of the United States? Are there examples maybe where donors have a say on who could receive the organ or other countries using algorithms for this process?
So I didn't systematically review that as part of my work, but I came across some of it in a sort of incidental way. One of the interesting questions that has happened abroad, there are a couple of things. One, there's an international consensus not to have a market in organs, but there have been places where that is relatively relaxed. And so there's been international tourism, for instance, historically to the Philippines and to India and to China for some of these organs. And a lot of that stuff, the underlying facts are quite difficult to tease out, and there are conflicting accounts, and the epistemology of it gets complicated. And again, isn't something I delved deeply into. But another question is, what if someone had a discriminatory preference? For instance, they said, I'm willing to donate an organ, but only if the recipient is a member of the same religious group or caste or race or something like that I'm a part of. And in general, across the world, that's not done. And including, of course, in the United States, the organ donor has no influence unless they're picking a particular recipient, as they can for kidneys, because we each have, in general, 2 kidneys and can donate one of them while we're still living. And so people do that and they pick someone that they want to receive an organ. And you can pick an individual, but the kind of categorical preferences that some people might have are not incorporated.
Do you think that laws mandating stakeholder input systems for less regulated algorithm-dependent industries are in our future? Thinking of like consumer credit, background screening, university admissions.
I hope that input practices are going to become more common. I'm skeptical about the role of legal requirements, legal commands in general. I think when you etch into the relative marble of a statute that you're going to have an advisory committee, often there's or a committee to make a decision, there's often practical drift that happens on the ground where practices change, but we can only rarely revisit the content of a statute just because legislatures have limited bandwidth. And so it's often the case that, for instance, notice and comment rulemaking will get etched into stone, but is today seldom used by federal agencies. And so I think something that's more organic and more perhaps voluntary, I think has a better chance. The UNOS example, the transplant example, is an interesting hybrid. But I think that if we're going to have voluntary input mechanisms, we need people to be smart consumers of claims that get made about how the system is working or how the input is being considered. And so part of the project of my book and of my career as a participant in this conversation is to increase the overall literacy level that people bring to discussions about designing algorithms for high stakes choices.
Thanks. So one last question. Is there anywhere we can find some of the works in progress, maybe papers or any writing you have for the book before the book comes out so we can follow the progress of your research?
Absolutely. So I'm DG Robinson on Twitter, and there's a website. I have a personal website that's the link from the Twitter profile that will point you toward my writing, including on Medium. And there's a CV or Google Scholar list that has all of the scholarly pieces. And I think a big part of what I'm doing is to take some of the sort of scholarly pieces and make them more accessible and to integrate them into a set of guiding questions that can be taken across different contexts. And I should also say that thoughts that people have about examples, like if people are thinking, I'm seeing an algorithm get used to make important choices today, and it's not part of the conversation in a way that I think it should be, that we're having about algorithms in general, like please reach out, because I'm in the process now of reporting the book, and it will be based on lived experiences and stories, both from the side of people who are being judged, which is something that I think is often covered by journalistic and narrative kinds of sources. But also, I'm really eager to get the perspective of the architects and of people who are faced with the hard choices that these algorithms help us to resolve. So, the surgeon, the person hiring people, the judge in the courtroom, or people building systems to help these people make decisions. Because I think that side of the challenge can easily get lost. And part of the hope of the book is to chart a middle path that acknowledges not only the problems that can come from the use of these systems, but also the significant benefits and the inescapably difficult problems that many of these algorithms are designed to help us resolve.
David, thanks so much for sharing this rigorous, illuminating work with us. And thanks to all the participants for today's HI seminar. I think we can conclude here, and I'm really looking forward to your book.
Oh, thanks. And thank you, everybody. Really appreciate it.